Welcome to the training course on IBM Scalable Architecture for Financial Reporting, or SAFR. This is Module 16, Effective Dated Lookups. Upon completion of this module, you should be able to describe uses for effective dated lookups, read a logic table and trace with effective dated lookups, explain the function codes used in the example, debug lookups with effective dates. The prior modules covered the function codes highlighted in blue. Those to be covered in this module are highlighted in yellow. Many reporting applications perform effective date processing for spotting trends, performing what-if analysis, analyzing changes in position, reconstructing historical perspective for audit and other purposes. As you can see in this example, the number of customers by division by year is shown. SAFR's date-effective joins provide a powerful way to perform these types of functions. Changes in reference data can be maintained to allow for recreation of reports as of a point in time. This can be done in individual views, or as a view might include multiple as-of dates. We'll expand our example by including a new table, the Customer Name Table. This table is keyed by customer ID. This customer system tracks changes to data via effective dates to keep track of changes to people's names, perhaps when they get married. To do so, it has an additional key to the table, the effective start date. Thus, for the same customer ID, it could have two names, each effective for a specific time. When using tables structured for SAFR effective dated joins, the same primary key value can have two different sets of attributes. The effective start date is used to distinguish between the two values, meaning when each record became effective. The start date of all zeros means the record has always been effective. In other words, it has been effective since the earliest possible date. In this example, two different start dates are used to search the reference data for customer 5. The first is 2012, and so it returns the record which started in 1985. Customer 5's name in 2012 was Sally Rogers Smith. The second query is for 1984, and so the earlier record for the earliest possible date is returned. Customer 5's name from the earliest possible date until June 22, 1985 was Sally Rogers. SAFR assumes that the effective end date of the first record is the start date of the next record. In many applications, exact binary matches of keys require the data values to be exactly the same, including the effective date. This can require many duplicate records to have all possible dates covered. SAFR doesn't require this. It tests for the most recent effective dated record, falling back from that key date provided to the last effective record. This can significantly reduce the size of effective dated reference files, which thus use less in-memory while processing and performing high-speed joins. SAFR also provides the ability to use an effective end date as well when an explicit end date is stored on each record. This is useful rather than assuming that the effective end date of the first record is the start date of the next record. This functionality allows for gaps when no effective date record may be in force. When using end date processing, SAFR starts with the same fallback logic to find the earliest start dated record. It then performs one more test, checking to see if the date provided is also less than the end date. If it is not, SAFR returns a not found condition. The 1984 search returns a not found condition because the effective date of 1984 is between the 1983 end date of the first record and the 1985 start date of the next record. This same functionality in other tools can consume a lot of CPU resources testing for valid date ranges. SAFR effective dated search is very efficient, on the order of 2 additional CPU instructions for each effective date test. The effective dates, both start and end, are defined on the logical record. There can be only one start and one effective end date on each LR. Both parameters are optional, but an end date requires a start date be defined. They can be located anywhere on the LR. In this example, the customer name LR has both a start and an end date defined. The start and end date parameters should not be placed on the lookup path and do not affect how the LR path is constructed. Fields listed in the lookup path are used for an exact binary match. Because the start and end dates are not exact binary matches, they are not placed on the lookup path. However, remember the start and end dates are marked as effective dates on the LR, instructing SAFR to use them during processing. In this example, only the field to be used to search the 10-byte customer ID is defined in the lookup path. Use of a start date or a start and end date affect the join phase processing. It's not possible to use just an end date. The value in these fields are added to the RED core image file at the end of the LR-defined key data. All field date effective dates are converted to binary, and SAFR will automatically convert all dates to the same content code of CCYYMMDD, regardless of the source date format. This is done to reduce the amount of memory used by them and ensure the test for effective dates test years, then months, then days. Note that even though dates are converted to binary format, no exact match dates is required. Note that the use of a start date parameter is the only case where duplicate keys are allowed in the SAFR join reference file. In this example, although there are 2 records for customer 5, the start date ensures uniqueness in the search results. Like all other RED core image files, it must be in sorted order by 1. The key, such as the customer ID in this example, 2. The start date, and 3. End date if used. The effective date used in the search key can come from 3 different places: a constant placed in the view, a constant fed to the performance engine programs in the job stream, or the value from a field on the source event file. Each of these will be discussed in the following slides. A constant as of effective date value can be hard-coded in the view. To do so, place it immediately below the path in the column parameters. If used, the same value will be used for all lookups for that column. The value would have to be updated manually if the view is reused. For example, to report processing results as of the end of every month. In this example, all customer names as of 2010-0101 would be extracted in column 2. Use of this approach is effective for 1. Unit testing views, and 2. One-time views to produce particular reports for analysis, or for future dated views to do what-if analysis for reorganizations. A more frequently used option is to use the run date parameter. The run date can be set in GenevaERS step of the selection job for the performance engine. If the parameter is not sent, GenevaERS will default to the system date. Thus, each day of a new VDP is created, the run date will be evaluated to the current date. In our example then, although the view might have been created in 2010, if GenevaERS is run in 2012-10-03, all customer names as of that date will be extracted by our example view. Often, rather than using the system date, which might change arbitrarily at midnight, a small program is created to pass GenevaERS a fiscal date of some predetermined kind. A fiscal date allows all views running at the same time to use the same date. Also, even if a set of views needs to be rerun on another date, they can be set as of the required date. For example, running reports for the year end December 31st can be done even though the system date is January 1st. A field on the source event file can also be used as an effective date. This is similar to using it in a lookup path, although it is not placed in the path and the exact match of the value is not required. If used for effective date joins, the date used can vary record by record, unlike the other 2 date constants described. In this example, the date became customer field is used to find the customer's name when they became a customer. The report is not as of 2010 or 2012, but varies customer by customer depending upon the date stored in the customer event file. Each use of a lookup path containing an effective date in a view requires specifying which date should be used for that join, either a constant, the run date, or from a field. Thus, a single view can use all three sources for different joins. Next, we'll examine the logic table generated by three different options. The view constant and run date effective date joins use an LKDC logic table function code. Remember, LK functions build lookup keys prior to performing searches of core image files. LKD functions build lookup keys containing dates for effective date joins. LKDC builds a lookup effective date from a constant. The only difference between the view constant and the run date is the source of the constant. The view constant is the value placed in the view itself. The run date constant is placed there by GenevaERS at runtime. One cannot detect which source was used for effective dates by examining the logic table. In this example, the view constant is 2010-0101. The run date constant is 2014-0404. Because all effective dates are converted to 4-byte binary, a FM type 6 on the logic table report, which can potentially hold 10 digits, an additional 00 is appended to the end of the date constants for join processing, but does not affect the source or the target dates. The view using a source event file field for date effective join uses an LKDE logic table function code, which builds a lookup key effective date using the value from a source event file field. Rather than seeing a specific date in the logic table, the value to be used will be moved from a field. This is like an LKE function, but used for effective dates. In our event file field example, the field ID 68, date became customer, will be moved to the lookup key effective date position. As noted earlier, all these dates are given a 4-byte binary, FM format code 6, with a CCYYMMDT content code number 3. The constants are put into these formats in the logic table to save CPU cycles during runtime. Thus, they are listed in these formats as source. The date for the event file field will be converted to this format as the date is read during execution. Next, we'll trace records through these logic tables. We'll use the reference file as the target of our join, searching against customer ID 1, Michael Clark. We'll show what the results of this effective date search will be for various date combinations. The logic table trace for one record against all views is shown here. Each view executes an LKE to move the customer ID 1 to the lookup key. Then each executes the effective date build, either an LKDC or an LKDE. The LUSM lookup function is performed, and then the customer's last name is moved to the extract file through a DTL data lookup function, and the record is then written using a WRDT write the extract record data area function code. We'll examine the details of each of these on the following slides. Let's examine the LKDC and LKDE functions more deeply and what effective date is used in each. At the bottom of the screen is shown the effective start date for the target reference file record, 1961-03-15, and its end date is all nines. Since all three LKD effective dates, 2010 for the view constant, 2014 for the run date, and 1999 for the event file field, are within this range, the results for all three are found conditions. Note that the value for the LKDE is not shown in binary in the trace because the source data is not binary. Conversion to binary takes place as part of the logic table function processing. In this example, we've changed the reference file record effective date to start in 2011 rather than 1961. The view constant compares the LKDC 2010, which is less than the start date of 2011, resulting in a not found condition. The run date compares the LKDC of 2014 to a start date of 2011 and finds the reference file record is effective, and so the results in a found condition. The LKDE field value contains 1999, which is less than the start date of 2011, and thus results in a not found condition. Thus views 1 and 3 use DTC function codes, move a date constant to the space because of the not found condition. In this example, we've changed the reference file effective end date, not the start date, from a very long time in the future, all nines, to a while ago in the past, 2001. The view constant compares LDate LKDC 2010, which is greater than the end date of 2000, resulting in a not found condition. The run date compares the LKDC 2014 to an end date of 2000 and finds the reference file record is no longer effective, and so results in a not found condition. The LKDE field value contains 1999, which is less than the end date of 2000. The reference file record is still effective, and thus results in a found condition. Thus views 1 and 2 use DTC functions to move a date constant of spaces to the extract file. In this example, we've added another reference file record for customer 1, reflecting a name change to Clark-Smith. However, there is a gap between the two records. One still ends in 2000, but the new one doesn't start until 2011. The view still requires an as-of date of 2010-0101. There's no change to the view constant process. The lookup key is primed with customer 1 and the LKDC effective date of 2010. The search finds Clark record because the new record doesn't start until 2011. After finding this record, the program compares the effective LKDC date constant 2010, which is greater than the end date of 2000, resulting in a not found condition. The run date view primes the key with a customer ID of 1 and the LKDC effective date of 2014. Therefore, the binary search returns the second record with an effective start date of 2011. The performance engine then tests the LKDC effective date of 2014 with the end date of 9999 and results in a found condition. The customer name of Clark Smith is used in the output column. The field value view primes the key with a customer ID 1 and an LKDE field value of 1999. The search returns the first reference file record with the start date of 1961. A comparison of the end date of 2000 to 1999 shows the record still effective, and thus the results in a found condition. The view uses the last name Clark to build the output record. In this example, we've modified the customer name logical record so there is no effective end date field. If no end date field is defined on the LR, the start date of the next record is the implicit end date of the prior record. First, the view constant searches with an LKDC constant of 2010, which is less than the 2011 of the second record, but greater than the 1961 of the first record. Thus, the 1961 record is effective. It uses the last name of Clark to build the output record. 2. The run date view searches with an LKDC value of 2014 date, which returns the second record with a start date of 2011. Because there is no explicit end date, this record is assumed to be effective forever. The view uses the Clark-Smith value to build the output record. Third, the field value view uses an LKDE date of 1999 and has the same results as the view constant. Thus, all three views have found conditions. This trace shows event file records beyond the first record for the event file field view. Note that the trace shows that the date used in the LKDE function code changes with each event file record, whereas the constant used in the LKDC would remain the same throughout the run. The relationship between these dates might be summarized as 1. The view constant date is always the same, even in between different executions of the view in the performance engine, if the view is never manually updated. 2. The run date constant is the same within an execution of the performance engine, but can change depending upon the system date or parameter passed to GVBMR86 between executions. 3. The event file field date can vary within an execution of the performance engine as the dates within the source event file field change. The following are a few more common reasons why you may encounter an error in effective date processing and possible approaches to each. Effective dates should not be included in the lookup path. If they are, the dates will be moved by an LKE function instead of the LKDE or LKDC function, requiring an exact match, not an effective dated match. Because the source of an LKDE is a field specified in a view rather than on the lookup path, it is possible to use different LR fields, resulting in different output results per view when similar results were expected. Improper content code definition for LR dates, either the join or the event LR, such as MMYYDD, will result in not found conditions. Views can be hard-coded with effective dates rather than using the run date parameter or a field value. Because each use of the lookup path contains an effective date in the view, inconsistent use of constants, run dates, or field values can provide unexpected results. Improper parameters passed to GenevaERS can set an incorrect run date. This module has introduced the following logic table function codes: LKDC, which builds a date-effective lookup key from a constant. LKDE builds a date-effective lookup key from a source event record. The following function code was not shown in the example. LKDL builds an effective dated lookup from a looked up record. This module described effective dated lookups. Now that you have completed this module, you should be able to describe uses for effective dated lookups, read a logic table and trace with effective dated lookups, explain the function codes used in the example, debug lookups with effective dates. Additional information about SAFR is available at the web addresses shown here. This concludes Module 16, Effective Dated Lookups.